In this episode, we're going to build a clear, beginner-friendly understanding of what it means to secure cloud architectures, because cloud security is often misunderstood as either completely handled by the provider or completely out of control. The reality lives in the middle, and the middle is where the most important security decisions happen. Cloud environments can be very secure, but they are secure for different reasons than traditional environments, and they also fail in predictable ways when people carry old assumptions into new designs. The cloud introduces a shared responsibility model, which means the provider and the customer each have responsibilities, and confusion about that boundary is one of the biggest causes of real-world security incidents. The cloud also makes it easy to deploy systems quickly, which is great for speed, but speed can magnify mistakes when defaults are misunderstood or when permissions and exposure are not carefully controlled. By the end of this, you should be able to explain the shared responsibility concept in plain language and recognize common misconfiguration traps that create unnecessary exposure. A good starting point is understanding what cloud architectures are at a high level, because the cloud is not one thing. It is a way of delivering computing resources through managed services. Instead of buying and operating physical hardware in your own building, you use a provider's infrastructure and services to run applications, store data, and connect networks. In a cloud architecture, you still have compute, storage, networking, identity, and monitoring, but many components are abstracted and managed through provider services. This changes security because the control points are different. You might not be patching a physical server, but you still must control access to what runs on it and what data it touches. You might not be racking network devices, but you still must decide how networks are segmented and what is exposed to the internet. Cloud security becomes a practice of controlling configuration, permissions, and design, because those are the levers you use. For beginners, the key idea is that the cloud does not remove security responsibility, but it does shift where that responsibility lives. The shared responsibility model is the core mental model for cloud security, and you can think of it as a line that divides what the provider secures from what the customer must secure. The provider is typically responsible for the security of the cloud, meaning the physical data centers, the underlying hardware, and the foundational services that customers build upon. The customer is typically responsible for security in the cloud, meaning how they configure services, how they manage identity, how they protect data, and how they design access. The confusion comes from the fact that the boundary changes depending on the type of service being used. In more managed services, the provider may handle more of the operational security tasks, but the customer still controls configuration and access. In less managed services, the customer may be responsible for more tasks like patching and hardening of operating systems. For beginners, the most important takeaway is that you cannot assume the provider covers your security needs just because the infrastructure is hosted elsewhere. Your mistakes in configuration can still expose data or create attack paths, even if the provider's infrastructure is well secured. A useful way to understand shared responsibility is to separate responsibilities into layers: physical infrastructure, virtualization and platform, operating systems, applications, and data. The provider usually owns the physical layer and much of the platform layer, which reduces a lot of burdens that organizations use to handle themselves. The customer often owns the application and data layers, which are where the most sensitive business outcomes live. Depending on the service model, the customer may or may not own the operating system layer, but the customer nearly always owns identity and access decisions. Even when the provider manages the operating system for a managed service, the customer still decides who can access the service and what that access allows. For beginners, this is critical because many incidents are caused by someone leaving a service accessible to the public or granting overly broad permissions, not by the provider failing at physical security. Shared responsibility is not just a slogan. It is a guide that tells you where to focus your effort. If you understand the boundary, you can allocate time and controls to the parts you truly own and influence. Cloud architectures also change the security mindset because configuration becomes the primary form of control. In traditional environments, security might feel like it is built around appliances and network choke points, with a strong sense of perimeter. In the cloud, the perimeter is more fluid because resources can be created and removed quickly, and because services communicate through defined policies rather than through a single physical gateway. This does not mean the cloud has no boundaries. but it does mean the boundaries are often defined by identity, permissions, and service-level rules. For beginners, the key shift is to treat configuration choices as security controls in their own right. A configuration that allows broad public access is not just a convenience, it is an exposure decision. A configuration that allows any internal service to talk to any other is not just simplicity, it is a lateral movement risk. Cloud security success often depends on designing these rules intentionally and reviewing them continuously, because drift happens as teams make changes over time. One of the most common misconfiguration traps is accidental public exposure, where a resource that should be internal ends up reachable from the internet. This can happen through overly permissive network rules, overly broad service exposure settings, or mistakes in routing or gateway design. Beginners often assume that a resource is private by default because it feels like it is inside an account or a virtual network, but privacy depends on explicit controls. Another reason exposure happens is that teams test something quickly, open access for convenience, and then forget to close it, especially when environments grow fast. Public exposure is dangerous not only because it invites direct attack, but also because public exposure increases the probability that automated scanning will find the service quickly. Many attackers rely on scanning at scale to locate exposed services, so a single misconfiguration can put you into an attacker's funnel without any targeted effort. For beginners, the takeaway is that exposure is a first-class risk in cloud architectures, and preventing accidental exposure is one of the highest impact security habits you can develop. Another common trap is over-permissioning, which often appears as granting broad rights to identities because it is faster than designing precise access. In cloud environments, identity is often the most powerful control plane, and overly broad permissions can turn a small mistake into a major breach. For example, if an application identity has permission to read and write across many data stores, then compromising that identity can lead to large data exposure. If a human administrative identity has broad access and weak safeguards, a compromised credential can give an attacker sweeping control. Over-permissioning also creates hidden risk because permissions accumulate over time, and people often do not remove access when it is no longer needed. For beginners, the key idea is that permissions are the keys to the environment, and the cloud makes it easy to create many keys quickly. Least privilege is therefore not an abstract principle. It is a practical necessity to keep the blast radius small. When you design permissions thoughtfully, you reduce the impact of inevitable mistakes and inevitable credential compromise. A third common trap is misunderstanding defaults, especially when defaults vary by service or when settings are inherited in surprising ways. Beginners sometimes assume that if they did not explicitly enable something, it must be disabled, but cloud services often have defaults designed for usability, not for strict security. Defaults can include logging settings, encryption settings, access settings, and network exposure settings, and not all defaults align with the organization's risk tolerance. Another aspect of defaults is that security posture can depend on how services interact, such as when one service grants access to another through roles and policies. If you misunderstand how those interactions work, you may accidentally create privilege chains that are broader than intended. For beginners, the key lesson is that you should treat defaults as untrusted assumptions that require validation. Cloud security incidents often happen not because someone intentionally made a reckless choice, but because someone assumed a default was safe. Secure design means you actively confirm what settings mean and what access they imply. A fourth trap is weak visibility and monitoring, which is especially dangerous in cloud environments because change happens quickly and resources can be short-lived. If you do not collect the right logs and do not monitor key events, you may not notice that a resource is exposed, that an identity has been misused, or that data has been accessed unexpectedly. Visibility also depends on having a good inventory of cloud resources, because you cannot monitor what you do not know exists. Beginners sometimes assume that the provider's platform automatically gives full visibility, but visibility depends on what you enable, what you collect, and how you analyze it. Another common issue is logging that exists but is not actionable, either because it is incomplete, not retained long enough, or not integrated into investigation workflows. For beginners, the takeaway is that cloud security requires intentional visibility, including identity activity, configuration changes, and access patterns to sensitive data. Without that, you are relying on hope, and hope is not a security strategy. A fifth trap is treating cloud networking like traditional networking without recognizing the different control points. In cloud environments, network segmentation and exposure are often controlled by service-level rules and virtual routing design, and small mistakes can create large exposure. For example, allowing broad inbound access for convenience or failing to separate sensitive workloads from general workloads can make lateral movement easier if any one system is compromised. Another issue is assuming that internal equals trusted, which can lead to overly open internal communication. Cloud architectures benefit from designing networks around least privilege, where services can communicate only with what they need, and where sensitive data stores and management interfaces are protected tightly. For beginners, the key lesson is that cloud networking is powerful and flexible, but that flexibility must be used intentionally. Good design reduces attack paths, while careless design creates hidden highways for attackers. When you bring these ideas together, securing cloud architectures becomes a discipline of understanding responsibility boundaries and preventing predictable mistakes in configuration, permissions, and visibility. The shared responsibility model helps you focus on what you truly own, especially identity, configuration, and data protection decisions. Common misconfiguration traps include accidental public exposure, over-permissioning, misunderstanding defaults, weak monitoring, and overly open internal networks. And these traps appear repeatedly in real environments because the cloud is fast and complex. For beginners, the most important takeaway is that cloud security is not about fear of the cloud. It is about respect for the control plane. Your cloud environment is shaped by policies and settings, and those choices are security decisions whether you realize it or not. If you learn to think in terms of boundaries, least privilege, deliberate exposure, and reliable visibility, you will be able to evaluate cloud architectures with clarity and reduce risk without needing to become tool-specific. Secure cloud architecture is built through intentional design choices and consistent operational discipline, and those habits are what turn the cloud's flexibility into an advantage rather than a liability.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.